So the theory of plate tectonics are that huge pieces of crust in the mantle all fit together on the Earth's surface. How is this different than the theory of continental drift? Well, one deals with the continents themselves, the actual pieces of land, and this is the plates that the continents and the ocean floor are floating on and are how they're fitting together. So most of the plates contain the continents, like here you can see Africa, and has the ocean kind of surrounding Africa and this piece and how it moves together. So even though the continents are up higher on it, it's all one piece and it's moving separately than these other plates. Now this shows all the major plates, although there's a bunch of micro plates, and the end of your chapter actually talks about that, and it's kind of interesting if you want to go look up a little bit more information. So the movements of plates are responsible for most continental and ocean floor geologic features like islands, mountains, volcanoes, valleys. All of these types of things are basically created by these uh, tectonic plates. So I want to show you some different boundaries on the plates. There's three that we're going to talk about. Um, and maybe it's better to stay up here and look at this picture while we do it. The first one is a divergent boundary. And a divergent boundary, you can see that's where the arrows are going in opposite directions, like right here. Okay, a divergent boundary makes a rift valley if it's on land, like a big valley, because it's like spreading apart, so it's ripping that land, so it makes a huge valley. Or in the ocean, it will actually make a ridge. So it'll almost make a little mountain, like the reverse. And that's because it'll bring up volcanic magma from down below, will come and fill in that valley and kind of make a taller mountain. But more like a ridge. So divergent boundaries make a rift valley on land or a ridge in the ocean. A convergent boundary, that's a place where two pieces come together. So that can be seen like right here where the arrows are pointing towards each other. At a convergent boundary, you have two plates that are moving towards each other. So they're smashing into each other. And as they smash into each other, you can imagine what they make are mountains. They can also make volcanoes. They can also make island arcs, or like small islands get made along the way. And then another type of boundary that we're going to talk about that isn't shown here is a transform boundary. And a transform boundary is like what we have here in California. And that's two plates that are just grinding next to each other as one goes in one direction, one goes in the other direction. So they're kind of crushing like metal, two cars that are like touching, and one's driving south and one's driving north, but they're grinding past each other. It definitely leaves marks. It causes earthquakes where we live, and we'll talk about that a little bit more in a moment. So here's a few pictures of different types of convergent boundaries. So these are all convergent boundaries. The first one is an ocean on ocean, two pieces of ocean converging. And what's happening here is basically this piece of ocean is weaker for whatever reason, so it ends up diving underneath and subducting here. And when that happens, it can actually heat up this rock that will pop up as volcanoes so that it can make little island arcs, but it will go down as the conveyor belt. So here's two examples in the Aleutian Islands or Unimak Island in Alaska. The next one is ocean continental convergent boundaries. So here you're going to have a piece of the ocean boundary, which is usually lower and it'll be less hard than the continental crest. So the ocean crust will be the one that subducts. It will subduct down underneath the continent, the actual land above the ocean, and as it does that, the magma will heat up and it'll often burst through and make some volcanic mountain ranges. And some examples of that are the Andes mountain range, and the Osorno, Chile area is a lot like this. Actually, this is how California got a lot of their mountains, is we had an early subduction of ocean crust underneath us. It smashed us, so it kind of buckled the land, added a lot of volcanoes and mountains, and then inner United States tends to be very flat, where they don't have a lot of mountains. They have a lot of flat land, and that's because we got buckled here on the edge. And this buckling actually went as far east as some of the mountains, even in Utah, were all formed because of a subducting plate underneath us and the volcanic magma coming up and forming those a long time ago. And then you can also have continent on continent crushing into each other. And when two continents hit, they are also going to have a bit of subducting, but a lot of buckling above land, where you get huge mountains. You can get massive mountains like this. The Himalayas were formed when an ocean crust collided with a continental one. But once the whole ocean part had subducted, then the land that was attached to it hit. So then you had land on land hitting, and these giant Himalaya mountains were formed. And so that's it, just folded up and grew the Himalayas. So you can get very tall mountains that are formed when continents collide. Transform boundaries. I want to really look at this. We'll talk about earthquakes more later, but this is our current California boundary. Our current boundary is that two different plates are sliding or grinding past each other. And as they grind past each other, it's not going to be pretty. There's going to be earthquakes. There's going to be times where it just slips really quickly, or you get some good small little earthquakes that relieve some of the pressure along the way. So this is called a transform boundary. And the crust can be deformed, it can be fractured, but it isn't made or destroyed. It's just kind of two things that are smashing past each other as they move along. And that's what causes a lot of our California earthquakes. The San Andreas Fault, which is very long and runs all the way up through California, is responsible for that. So that is the end of that section, and we will move on to the next one.